What is up, guys? Welcome back to the channel. Today I'm gonna show you guys how to turn these battery cells into something that looks a lot like this. Well, actually Lord Curt's going to, and looks like he just pulled up right now. Oh yeah, what were you crimping there? What is this?
This is the negative discharge. So this is going to be right on here, and then we'll have the positive one, which I got on the floor here.
Okay, okay.
Positive
solid.
one will go up here. We'll have an exit port here and here. These are actually the connectors to the smaller accessory pack. I'm going to put these into some Deutsch connectors here, and so we'll have this coming out of the main pack. We'll have, you know, a multiple of these to make it so that they're all coming out, and then the accessory pack will just have another one that plugs straight into here, which allows them to connect in parallel. These are effectively the parallel connections. This will just keep each of the cells balanced. They'll be connected in parallel through the discharge with 2-gauge wire and 6-gauge wire, so the whole pack voltages will always stay the same, but it'll just ensure that each of the groups, each of the cells in the parallel group keep the same voltage too, so that's what this is for. Otherwise, the only thing we got to do is put BMS wires attached onto each of these posts. We'll have the accessory packs here, and then the BMS will go attached to the negative post. It doesn't make any difference which one it attaches to. These are electrically the same between these two, but it just gives me a consistency with this one being one thing and this one being a different thing each time. So we can see where that goes, but we just gotta wait till the BMS gets here. Otherwise, the pack's done. I've just gotta figure out how to connect it to the next pack, which is all we're working on here. These are the original bus bars that came with it. Probably could have handled it, but I knew that if I put it together, I would have just been wishing that I had made something better. So I went out and got some copper pipe, hammered it flat. We'll cut it in sections first, so it's the same length, hammered it flat, and then drilled out holes for it. So this is all put with heavier copper bus bars on there. They didn't also give, they only sent us 1 bolt per pack, which means we were going to be too short ultimately, because you're going to use every one, and then there's the one that it starts and ends, you're going to need to use 2. I just got 102 volts.
He's all amped up.
Yeah.
Like, yeah, let's do this. Let's build this battery.
First time I've been shocked by this one. So
how'd it feel?
You know, it's a little more powerful than the last one. I needed to buy some. It's just M4. In case anybody buys the same one, these are the Vericore 90 amp hour, but it's just an M4, so 4mm metric screw. And then I got some washers to go with that. They're better than the washers they sent. The washers they sent were
for sure
pretty flimsy. And there's zinc actually, so zinc's fairly conductive. It's not like it's a steel washer. Most of the washers you buy are zinc. So.
Solid.
Yeah, we're on our way.
Yeah, dude.
We made some cool little carrying handles too.
Yeah, we did.
So it's 135 pounds, so you don't want to be trying to fumble with each of the ones separately. So
yeah, if you're watching, this is probably like your sister or something just sitting on this. Like you're, you know.
And
anyway,
if you put this and the other pack together, that weighs the same as your mom. So it's a 32 series lithium iron phosphate battery, and I mentioned some of the advantages last video. If you haven't seen that, go ahead and watch it. But more stable, more life cycles, able to be abused, it won't catch fire, that kind of thing. But it's a little heavier. Regardless, for this one, we needed to have a form factor that would fit within the frame of the bike. So it's going to actually sit in, this will be the top, this will be the bottom, and it'll kind of basically tip up towards me, so this is on the back. We had 11 cells in series this way, and then we needed to connect it to the next one over, so I just made a 2-gauge bus bar that goes across this, and then this one gets connected here. Ultimately, it's really easy. It's just you stack them up, alternating orientation, and you go positive to negative, positive to negative, positive to negative. So these are all adding in series. So it's just one screw-in connection rather than having to spot weld a bunch. I mean, this effectively is the same as 30 18650s, all wired in parallel. I mean, you could do the math on it. It's 90 amp hours. Each one of those is usually 3 amp hours. This just all adds up then, and we got this one that runs down here, and then I've connected it. What I needed to have is my positive and negative, which I won't touch again this time. I need to have those both on the bottom so they can run up and connect to the accessory pack and then ultimately to the controller. So I had to run back up to the top to then start running this one in series back down. So what we end up getting is both of these discharging down on the bottom. I'm going to just run those in here. This is going to be housed in a metal case with a lid that goes on it, and we'll just silicone it all shut. The BMS will sit right here. I wanted to be able to drill 2 holes, one here, one here. So these will then have the discharge cables going up. I've actually got to round these out still. I forgot to do that. Notice I've done a couple of these where I rounded the bottoms out so that they're not sharp as the wire runs past it. I'm going to do the same thing here and here because these are discharging past there. So I want to make sure that wire's not going to get cut into at any point and then short circuit and kill the pack. And then along with those discharge cables that are coming out, we're going to have the accessory pack cables coming out of it too. So this will just plug into the other one and allow them to connect in parallel. I mean, otherwise it's not much more to describe. It's extremely simple.
Yeah.
I just made sure that it was able to carry enough current. I wanted to be able to have this one supply 300 amps minimum without really having any issues. The cells are rated for 3C, so that means that they can continuously discharge 270 amps. But you can peak them a little bit higher than that. We're not going to ask that of it, so it'll handle it easily. But I just want to make sure the bus bars are able to do the same, so I went ahead and built an upgraded one.
Dang, okay. That's a little bit smaller than I thought it would be, to be honest. I guess it doesn't have to be huge though, huh?
Yeah, I mean you can see the bus bars that carry.
Oh,
it's a
yeah,
fat
okay.
piece of copper,
Oh, shoot, okay.
Power is able to flow through it.
You're right.
It's 100 amp that it's rated for. So if we wanted to, you could get a charger that would charge the battery from empty to full in an hour and a half.
Dang, son.
Through this.
Freak.
But
that's awesome.
You get all kinds of special power outlets.
Yeah. But you could.
You could put an onboard charger that flowed through here that would plug into like a Tesla charger. But you're talking like $1,000 just for
right.
that.
That's true. Yeah.
So
not worth it.
So but in the event that you're like, you know what, I really wish I had a nice onboard charger. And you drop money in the future, you could. Then you
exactly.
Could and fill up.
When we're balling out, when we can we can put a Tesla charger right on the bike. You guys saw on Instagram too. This thing's looking good already, but we still got to paint it. We got to do all that good stuff. But it fits perfectly.
Fit on there.
You want to just explain what y'all's doing over here for them subscribers?
Sure. We're running some balance wires right now. So this is an interesting pack because we got the expansion port, right? Only because we're connecting to the accessory. So on each of these bus bars, we've got 2 coming off. One of them is just for the balance. It's a parallel connection to the other pack, basically, to keep this cell and the first cell of the other pack at the same voltage. These ones are the balance wires for the BMS, which we've got attached here. And I'm going to set that carefully there. You can see running those all out. Each bus bar is going to get one at least. And it's just going to balance each of those cells. Are going to now be kept at the same voltage as it's charging. When it's discharging, we're bypassing it. So it's only going to run the charger through the BMS. It's only 100 amp BMS. If you get a 500 amp BMS, which is what we would have needed, it would probably run you, I mean, I don't know, $500 to $1,000.
A lot more, yeah.
But all you got to do is, if it's charged each time, if it's balanced each time it charges, and then you discharge it, and you cut it off like a volt or two above, then you're going to end up having no risk of damaging the cells. So we'll just charge it and have it be balanced when it charges. So the discharge is just going to go straight through here, beefy wires, no need to worry about current. The balance wires are going to then, as it's keeping these voltages the same, it'll just run to the other pack and keep this connection, this electrical connection, balanced between those two. So both the packs have the same voltage. Ultimately, the two packs are going to also be connected through discharge. So as it's pulling power from both, if one drains faster than the other, it's going to be recharging and balancing out the whole pack through this. But these connections just make sure that the two cells stay the same voltage. So there's no risk of one becoming imbalanced or more voltage than the other as they're discharging. You say one discharges faster. No risk of that because it's going to be balancing through the discharge port. Here's the diagram of where everything's going. Obviously, it's all hypothetical and it's showing lithium-ion batteries. So this is a smart BMS, so it's going to be able. You can adjust if it's a LTO or if it's a LiFePo4 or lithium-ion, whatever. You just tell it what it is. But we're going to have the black wire along with the B- wire going to the negative of cell 1, which I did. And then we're just going to connect one to each of the bus bars to be the 1 positive, 2 positive, 3 positive, the whole way down. But the very end one, there's 2 balance wires that go to the 32 plus. One is for that cell. It's this white one here, the first white one. That makes the cell voltage balance. And then this red one, with the black and the red one, it reads the full battery voltage, the pack voltage. So it's balancing the cell and then making sure that the whole battery is at the voltage that you want it to be at. We need to have it come through the lid to that before we can actually build this. So I just built a temporary 12 gauge version of this. This is the charger connectors here. I'm just going to try to get it charging so we can program that, because if we need to do anything to it and it's in the case, we can't.
Right.
So I got to plug it in so we can test it and see how it's working before we can do this. So this is a nice charger, though. It's actually really nice.
Yeah, dude. It's got a handle and everything.
We'll see what happens.
Okay.
Okay, it powered up. You heard that beep. So that's running. This is beeping here. It looks like it's trying to pair. I got the app downloaded on my phone.
Super cool.
Wherever my phone's at.
Ooh, let's see what you're seeing.
Okay, so that's the right voltage. It's currently charging with a 5.1 5,000 watt charge. Let's see if it registered. There's all the cell voltages. That's pretty dope.
That's crazy, dude.
So they're not all quite identical, but they're close. We don't want to charge it all the way up because we want to be able to have it be the same voltage as the other pack when we attach them.
Right.
But I just want to see if we can figure out. Oh, here we go. There's some more down here. Settings. There we go. Battery type. It's that. So. And then, oh, I thought it was 0% because it was 3.2 volts, which is the 0% of lithium ion. So I thought it was lithium ion there. I need to look up what the low, I think it's 2.85 is the low voltage for.
You hear it, listen. Next gon' give it to you. Get it on.
So for the sake of understanding this, I want you guys to ignore these expansion port wires. These cables are how it's going to connect to the other battery pack. Without it, and a lot of what you were watching was probably me putting these on. It took quite a while to get all those pins to go in there correctly. But without these involved, the process was pretty easy. It was just putting all the stuff in the shape we wanted, putting the bus bars on. The pack right now, just to kind of put it in perspective, I guess, this is where the discharge cables are, also the charge cables. We'll talk about which one's which in a little bit, but this is the start of it. This is the first cell, and then this one is the 32nd cell. So it just snakes its way up like this, back down, and then I jump it from here back up to here, and then the cells run down this way. The intention behind that was trying to make it so that they discharged and charged from down here, so I could just have holes on the bottom and not have to worry about running cables from the top back down. So I wanted it to be uniform down there. But ultimately these bus bars just add the voltage from here to here to here by connecting positive to negative, positive to negative, positive to negative. Same exact way we did the lithium-ion battery with the 18650s and the 26800s in the previous videos, which you guys can search those and watch those if you want more further explanation on that. But the only other piece we had to worry about was putting the BMS on this, which we got a really cool one. You probably saw some footage of the programming of that. It's right now, I think it's balancing. One of the cells is at 3.075 volts and high one's at 3.341 volts. So I think right now it's active and trying to balance those out. But the difficult part of this is just figuring out, and it's not difficult, it's a lot of work. You can see the number of wires. It looks kind of like a computer motherboard or something with all the cables coming out of here. But one of these, it starts from the bottom. So this is the first cell positive, or sorry, first cell negative on the bottom. And then it's got a first cell positive, second positive, 3 positive, 4 positive, 5 plus, 6 plus, all the way up through until you get to 32 plus. And then these last two wires both went to the positive one here. So you can see I actually have two wires in one crimp connector ring terminal on this. And this is the power line for the BMS. So this is what powers it and this is what balances it. So this is taking the full pack voltage and that's just taking a partial single cell voltage. I mean, we're pretty ready to put this in the case.
Yep.
We got the battery box here, which I'm going to line it with padding, top, bottom, sides. It's going to sit on its end. I believe this side goes down. And so there's going to be a lot of weight stacking down on these. It's okay for these. These are hard metal casings. The other little pack that we have, they're soft case, so we can't stack them like that. So we've got to do a more unique design with those. I've still got to figure out how that's all going to work. We actually had one of the cells. I'm going to bring it over here.
Yeah. Dude, I'll just follow you in here.
One of the cells had a crushed case. There's a metal shape around it, but if you notice, it's not perfectly firm. Some of them actually have bigger bubbles, but you can see I can push it out a little bit, maybe not.
Oh yeah, I can definitely.
So one little crush on this, and it started to leak out the electrolyte, which is it's kind of like a gel. It's not solid. So because we have one that got lost, we got 31 left, but you can't run a 32S pack with 31 cells. So seller's replacing it. I don't think there's any fault on his, just a little mistake. But you gotta be careful. This cell is different than those cells because it's a soft cell. So we're gonna have to stack these side by side at most on their sides, 2 maybe, but we can't get a whole stack of it because it's not able to support the weight.
Gotcha. But these are the other ones. So this is the expansion pack, right? The accessory pack.
Yep.
And there was just one bad cell in this whole shipment. So
and I mean that happens with anybody. These are it's a good cell. It's a solder top, not a screw top, so you actually have to have a big soldering iron so you can solder onto those tabs. But I want to say this is negative, this is positive. I checked it with a voltmeter just to see, but you can test which one's which. We'll do that one in an upcoming video. But the main pack is what everything's hinged upon. So we're able to kind of get everything built with this. The next step for what this is, we can hook everything up and we can run the electronics. We can see if everything's working. I mean, the only thing that one's doing is adding more range and a little bit of it won't heat up as much because you got able to put out more amps. As far as discharge and charge cables go, the discharge is going to discharge straight through these 2 gauge short run, so it's going to be able to pull a lot of current, no big deal. The downside of running it through the BMS is you actually have to have a BMS that's rated for that amount of current. This one's 100 amp BMS, so in order to manage the voltages on discharge, you'd have to have a BMS that can handle that. We're not going to worry too much about that. It's just going to discharge and then you won't let it run all the way to the empty.
Right.
So that'll be unrestricted, no stress on that. We're going to run it through an amp meter, a little shunt, so we can see what it's pulling, which will give us the amount of discharge that's happening and also the amount of regen that's occurring. It'll throw a negative number up when you're actually running backwards. That's super cool. So we'll see how effective that is and if it's worth doing or not. The charge cables do run through the BMS, and this is just temporarily hooked up. I needed to test it. So what happens is you're plugged in here, the power is running this direction. It'll run through the BMS, which then allows it to balance all the voltages before it heads into the pack, and then you have the negative and the positive. So and the way you wire these, there's good diagrams, which the one that we came with had a lot of instructions.
Alright, this is the final product right here. Just putting it in the box. You've been doing a lot of work on this project, so how much is that gonna set me back?
Oh man, I don't know if you can afford it. It's all the...
All I can give you is a card right now. This is my new extra wallet, and clearly guys, this is a little sponsored segment. Nothing big, but I just wanted to give a shout out to Extra. They hooked me up with this wallet, which is made from recycled windshields, apparently. I would never know that. It's kind of just like a leather minimalist wallet. So there is a link in the description if you guys do want to check it out. Thank you again, Extra, for sending me this. I really like it. That's pretty much it. Check them out. Link in the description.